Today we are going to take what we've reviewed about inequalities, about graphing lines, about writing equations from situations, and we are going to bundle it all together into something that is called linear programming, which you can see by the definition up here is the process of optimizing a linear objective function that has inequalities called restraints. We call the graph of the system of constraints the feasible region. We are using this in real life situations to optimize, which in real life, in the business world, usually, we are trying to find a maximum value, such as maximizing a profit, the amount of money that you make, or minimizing something, such as minimizing cost, which are obviously both things that a business would want to do. So we are going to walk through this example here, and then you need to be ready to walk through these same steps with your group in class on a group assessment tomorrow. All right, so here is the problem. A bakery makes blueberry bread and apple cinnamon muffins. For each batch of bread, they make a $35 profit. For each batch of muffins, they make a $10 profit. The bread takes 4 hours to prepare and 1 hour to bake. The muffins take a half an hour to prepare and a half an hour to bake. The maximum preparation time available is 16 hours. The maximum baking time available is 10 hours. How many batches of bread and muffins should be made to maximize profit? So we can see that this is our objective. We want to maximize profit. So I'm going to go through, all the steps are labeled, and it kind of tells you what to do. So step one is always to define your variables. And we are going to have P be our profit, and then we have two different things going on here. It says how many batches of bread and muffins should be made to maximize profit. So we're maximizing profit, that's why that's a variable, but it's asking how many. So that's why we make our variable the number of bread or number of muffins for those. Step two is to write constraints. There's a whole bunch of information in this problem, and we need to get it down into inequalities. So this is a system of inequalities. Notice it says use only the x's and y's. So that means we're not doing anything with the p just yet. And I've given you hints for all of these. First constraint. It says we want to write something that indicates that we can't make a negative number of bread. Well, number of bread is x. So I'm going to put x. If x can't be negative, that implies the inequality that it has to be greater than or equal to 0. So that is our first constraint, that x has to be greater than or equal to 0. Equation B, the hint says you can't make a negative number of muffins. So same idea. Y has to be greater than or equal to 0 because it can't be negative. That doesn't make sense for the real life situation. Equation C is from the actual words in the word problem. It says prep time can't be more than 16 hours. Now that's total prep time. So that includes both prepping the bread and prepping the muffins. Now, in this problem, they told us how long it takes to prep each. Bread takes 4 hours to prepare. Muffins take a half an hour to prepare. So, for every batch of bread, it's 4 times the batch. That's how long that'll take to prepare. Plus a half an hour, so 0.5. Why? Because that's how long it takes for a batch of muffins. And it says it can't be more than, which means it needs to either equal 16 hours or be less than. So less than or equal to 16. So that's equation C. Because we're taking the prep time for the individual items, multiplying it times the number of batches, and remembering that the total prep time has to be less than or equal to 16. Our final constraint has to do with baking time, which can't be more than 10 hours. This is very similar to C. So bread takes 1 hour to bake. Muffins take a half an hour to bake. So 1x, or just x, plus 0.5 for the half hour, y, and it can't be more than, has to be less than or equal to 10. So there are our constraints. We have constraints because we have to make it make sense for our real life situation. Your next step is going to be to graph these inequalities. So in order to put an equation or inequality in the correct form for graphing, that means we need y, and in this case it's not going to be equals, but either less than or greater than your symbol, mx plus b. Now, the first two are already in that form because those are going to be vertical and horizontal lines, because if you only have an x, that means it's vertical. If you only have a y, that means it's horizontal. So those ones are going to be easy to graph. Now, the other two, we need to get y alone. So we practiced this in the first couple sections. So first I subtract the 4x. So I've got 0.5y less than or equal to negative 4x plus 16. Divide by 0.5, which is the same as multiplying by 2. I'm just thinking as if it's in fraction form. So that's going to give me y. When I multiply both of these by 2, that's going to be negative 8x, and then that's going to be plus 32. Our last equation started out x plus 0.5. I'm just going to write it as 1/2 because it's easier for me to look at the fraction. To get y alone, subtract the x first. So that gives me 1/2 y less than or equal to negative x plus 10. So multiply everything by 2 over here. So y is less than or equal to negative 2x plus 20. Okay, so we've got our constraints written. We wrote them in a way that we're going to be able to graph them. So our next step is to actually graph them, graph the feasible region. And on yours, you've got a label on this axis. I couldn't type it, so I had to write that one in by hand. So we're going to graph the system of equalities from step number 2. Now, one thing you need to remember is how to shade on these. My first equation, x is greater than or equal to 0. So that's a vertical line where x is 0. Because it has the equals, that means it's going to be a solid line. You learned in Algebra 1 that solid lines for equals dashed if it doesn't have the equals. So I've got a solid line, and I'm just going to kind of color it. It's hard to do a vertical line on the computer here, but it's going to just be here. That's where x is 0, right on the y-axis. So there's our first graph. Second graph, y greater than or equal to 0. Well, that's a horizontal line where y is 0 is down here. So that's just going to be the same as your x-axis. Now, I can't erase. So when you are doing this, you probably want to shade as you go, because the first one is x greater than or equal to 0. So that means the values where x is greater than 0 is everything over here. Where y is greater than 0 is also everything in here. So right now, this entire quadrant would be shaded if we were shading it. Now we move on to the next one. Y is less than or equal to negative 8x plus 32. So if I'm looking at that, that means my y-intercept, my b is 32, my m is negative 8. So I need to cross the axis at 32, and I have a slope of negative 8. Now I'm counting by the same thing on both axes. So that means you can indeed go down 8 units and write 1 unit. So 1, 2, 3, 4, 5, 6, 7, 8 units is all the way down. right 1 is right here. Now, you should use a straight edge here. Mine is going to be really crooked just because I can't use a straight edge. Now, remember that this is an inequality, less than or equal to. Less than means that I would shade everything below that blue line. Again, I'm not shading it yet because I can't erase. You can shade it all in if you want and then erase other pieces later. All right, last item to graph, equation D here. We have y is less than or equal to negative 2x plus 20. So my b is 20, my m is negative 2. So that means I'm going to start up 20 on my axis, and a slope of negative 2 means I'm going down 2 units, right 1 unit, down 2 units, right 1 unit. So again, please use a straight edge on yours. There we go. Now, this one is also a less than. Less than means below. So I already have everything shaded that was below the blue, but now I need it to also be below the purple. So the overlap of your shading is everything that's in here. And again, you could shade and then erase this part that wasn't below the purple. It's easier to shade as you go rather than just trying to think of it at the end. So greater than 0 and on the X and Y meant this entire thing would have been shaded. To be less than the blue means everything over here below the blue should be shaded. And then once I add the final purple in, that means everything below it is my final shading. So everything in here is what we call the feasible region, meaning if you pick any point in there, it's going to fit the constraints that you have. So meaning it's not going to go over the maximum prep time or the maximum bake time as long as you pick a point that's inside that shaded feasible region. So feasible region is the overlap of all the shading. Now what we're going to do is calculate the corner points. The corner points are the vertices of the feasible region. So I'm going to use red here. The vertices of the feasible region mean the vertices of the shaded region. So here's one, here's another, because that's the shaded region corner. We're looking at it as if it were a shape. Here's one, and here's one. So we need to list all of those points. Now, I listed from A and B, from B and C specifically. So from A and B, those were the first two equations. Those two overlap here at 0, 0. B and C are this line and the blue line. Those overlap at 4, 0. A, which is the green line, and D, which is the purple line, overlap here. So that's the corner point for that. That's 0, 20. And then finally, the corner point from C and D is this one. Now, that's not on an exact amount. You need to make sure that you know exactly where that intersection is. So I would suggest using your graphing calculator and graphing them as if they were equal signs. So graphing y equals negative 8x plus 32 and y equals negative 2x plus 20, and find the intersection point. Remember that we do that using your second trace menu. So you go to second trace, and then it's choice 5 for intersection, and then go through the first curve, second curve. You could also solve the system of equations if you wanted to using substitution or elimination. So you could use that option as well, multiply the bottom by negative 4, solve it. When you do that, you should get 216 to be that final intersection point. it's always just going to be one that you have to do that. The other ones should be on exact points because they'll be on one or two of the axes. So now I've got my corner points. The point of the corner points is to find that maximization or minimization. So our objective here was to maximize the profit. And we haven't yet written an equation that represents profit. So that's what we're going to do now. Write our objective equation to maximize profit. So none of our constraint inequalities are going to be used. We're just simply relating P to X and Y. So profit, money. So go back to your original situation and look at the money because we haven't used the money yet. So profit equals, let's look what it says about the money. It says for each batch of bread they make $35 profit. So if number of batches of bread is X, that means 35 times X is the money they're going to make off of the bread. Now, they're not only making money off bread, they're also making money off muffins. So we're going to add the muffin money. So go back up and look. Let's see. For each batch of muffins, they make $10 profit. So plus 10y. So there is our objective equation. That is going to give us our profit. Now, I just said before we wrote that the corner points, the purpose of those is that one of those is going to be the optimization. One of those points is going to give us the maximum profit. To find out which one, we simply plug all four of those points into our profit equation and see which one gives us the highest number. So if I plug in 0, 0, that means profit equals 35 times 0 plus 10 times 0. Now, anything times 0 is 0. And I get a profit of 0. Well, that should make sense because if I'm not making any bread or muffins, I'm not making any profit. That is 0. That's clearly not going to be. B and C, X was 4, Y was 0 at that point. So let's plug that in. X was 4, Y was 0. So 35 times 4 is 140. 10 times 0 is 0. So that gives us $140 profit if we make 4 batches of bread and no batches of muffins. All right, now A and D, the point 0, 20. So 35 times 0 plus 10 times 20. So 35 times 0 is 0, 10 times 20 is 200. So I get $200. So if I made 20 batches of muffins, I would make more money than if I made 4 batches of bread. Last one, 216. So X is 2 and Y is 16. 35 times 2 is 70. 10 times 16 is 160. If I add those together, I get 230. 230 is the biggest number. So this represents our optimization. Our maximum profit is $230. Now, it says clearly answer the question that the problem is asking using appropriate labels. So double check what it is asking. How many batches of bread and muffins should be made to maximize profit? So we will say the bakery should make 2 batches of the blueberry bread and 16 batches of the apple cinnamon muffins. Now, it didn't ask, but other problems might ask. The maximum profit here we found is $230. All right, so again, linear programming is a nice way to bring all of this together in real life situations, something that people really have to do. in real life to find out or maximize profit, minimize costs.